For the fourth exercise, we are asked to write a to the power of b and store that result in C. Again, no data type specified. We can choose here. Again, we're going to choose to use simple 4-byte integers. About the second part of the question, so depending on how you wrote your code, it might be the case that it's easier to just make this assumption that b is always greater or equal to 2. Because if b is 1, then the result needs to be a, and if b is 0, then the result needs to be 1. So it could be that you would have like a certain structure where you have an if-else, if b equals 0, if b equals 1, and then calculate your implementation for b equals 2. Now, the solution that we're going to present, for the solution here, it really doesn't matter what your value of b is, it will always work. So this might not be relevant depending on how you approached the solution. And of course, there's many different ways of writing this. So if your solution is not exactly the same as ours, that's not a problem. If it's correct, it's correct. There's many different ways of writing a program. All right. So what we did in the data section is first reserve some space for A, B, and C. For A and B, we chose some test values. So we're going to calculate 2 to the power of 5 here. And then we loaded our values into registers. So we will use T1 for A. We will use T2 for B. And then we will use the T3 register to store our results. Very end of the function, the last line will store the value in T3 back into C using temporary register T1. So A is in T1, B is in T2, the result, the intermediate result, and the end result will be in T3. A good thing in the solution would have been to document this right here in the comments. Makes it a little bit less confusing. I'm going to do this right now. T1 has A, T2 has B, T3 intermediate result plus end result. There we go. All right, and I'll push this to your actual solutions as well. Great. So now if we look at this implementation, so first of all, let's look thinking about the special cases of b equals 1 and b equals 0. If b equals 0, we want the end result to be 1. And when is the end result 1? Well, so with this code, we loaded 1 as the result value. So if we would jump to the end right now, that means the case for b equals 0 has been handled. And that's what happens is the first line of the loop. It checks if, it checks if b is equal to 0, t2 is equal to 0. If that's the case, jump to the end. Since t3 is already initialized to 1 right here, the value is correct. Then, if this is not true, so if b was not 0, that means 1 will not be the correct answer. No, then we will have to multiply 1 by b at least once. Let's say b was equal to 1 or 2 or 3. Then we would have either b or b times b or b times b times b. So you will have to multiply 1 by b at least once. By a, right? So we will check here. If b is not equals to 0, we have to do another multiplication. So we multiply the intermediate result. So currently it holds 1. Let's say we're going to the first iteration. This holds 1. And we will multiply this with the value of a. Because a to the power of b is b times, it's like a times a times a times a times a, and so forth. And we do that b times. So the first iteration, this will multiply 1 with a, and the end result would be a. And a to the power 1 would indeed be a, so we would be done. We then decrement our t2. So let's say we are doing a to the power of 1. We would set t2, which is the value of b. We decrement it by 1, so b now becomes 0. And then we jump to loop. But remember, when b is 0, we are done. So if you jump to the loop with b equals 0, you're done and you will jump to the end and store the result. So if you would go through this code for the value b equals 1, these two lines would be executed once. 1 would be multiplied by a. Your end result would be 1. And indeed, a to the power of 1 would be a. And then for all higher values of b, if b is equal to 3, it will be decremented b times. So this multiplication, convince yourself that this multiplication will be executed b times. This loop will be executed b times because t2 is decremented by 1 each and every iteration. Eventually t2 reaches 0 after b times executing this multiplication. So b times you're multiplying a to a to a to a to a to a. And that's exactly what a to the power of b should be. So whenever this is done, the result is stored in C. So this is how we can calculate a to the power of b very easily in assembly. We just use a simple loop to do every individual multiplication. We could also see this in action maybe. So let's assemble this. We will now have the value 2 here, the value 5 here. And then if I single step, so right now our values are prepared and we're going into the first loop. So t1 has the value of a, we can verify this. t1 has the value of a, t2 has the value of b, and t3, the intermediate result, is 1. But our b value is still 5, and this is going to decrement each iteration, and then we will multiply t3 with a and store that result here each iteration as well. So the first iteration that's executed, we will multiply t3, and we did this, multiply t3 with a, and now 2 is stored there. And now we will decrement b by 1, so b will be 4 now, exactly. And this will be repeated. Now we will do the multiplication of t3 with a again. There we go, so it multiplied by 2 again. And if we keep on doing this times 5 times, eventually we will stop when b is 0. And then we store this end result, and 2 to the power of 5 is equal to 32, and that's the value remaining in T3 and also stored at the location C. That's it for exercise 4.